Swayam Prabha. Digital India. Educated India.
The next talk, the last talk for the session, is from Puneet Kumar Bhavsar from Visvesvaraya National Institute of Technology in Nagpur on the topic of systems engineering based time efficient health monitoring of COVID-19 patients.
Good afternoon everyone, I'm Dr. Puneet Kumar Bhavsar. I'm working as Assistant Professor in Electronics and Communication Engineering Department of Visvesvaraya National Institute of Technology, Nagpur. I'm going to present today's talk. The paper ID is 6980. The title is Systems Engineering Based Time Efficient Health Monitoring of COVID-19 Patients. The authors of this work are myself and Dr. Vinal Patel. This is the brief outline of today's talk. I will first discuss about COVID-19 and few statistics. Then I will talk about the general. Then we'll talk about how this framework can be used to monitor the health condition of COVID-19 patients. Then I will discuss the data set used in this study. Then I will talk about some processing, data processing, the machine learning algorithm, and the initial prototype we have developed here. And lastly, in the conclusion. COVID-19, a global pandemic, we have already seen it. Almost every individual was affected in one or another way. The health sector was at it. Impacted the global supply chain. Apart from these pertinent commodities, the surging demand of additional medical staff was another challenge to cope with. Developing countries are already deprived of availability of doctors, which are less than the standard ratio, that is 1000:1. One doctor per 1,000 population. This is the recommendation by WHO. The statistics reveal over 45% of member countries of WHO reports less than one doctor per 1,000 population. Even in India, only 11 states to treat an increasing number of patients. In such a time, smart technology with mobile devices and artificial intelligence can help doctors to allocate their time efficiently. Though the government from different countries have made digital platform available for reducing the infectiousness, but those digital platforms are not enough. So in this work, we'll see how the Internet of Medical Things based framework can be used to help in such situations. This is the general structure of Internet of Medical Things framework. It consists of three different layers for its functionality, starting from data collecting layer at abstract level to cloud storage and server at highest level, with internet gateways at the intermediate levels. Unlike other IoT applications, the IIoT requires to collect biological data for various applications. These biological sensors are broadly classified as either wearable sensors or non-wearable sensors. Wearable sensors are a subset of smart biosensors that can be implemented or used as extension on the human body. These devices have good prospect for producing data and communicating with other devices without the need for human interactions. We have several biosensors categorized as wearables with different applications in hearing aid, fitness tracking, chronic pain management, etc. Biosignals are quite often weak and noisy, making them challenging to interpret. As a result, they are first amplified with proper amplifiers. Internet gateways act as a bridge between the sensor device and cloud server to transfer data between them. The primary role of the gateway is to perform data normalization, data pre-processing, and provide network connectivity. Data normalization is the process of data conversion to a predefined unique format in order to perform the further processing. This is required due to the raw data from all the devices may not be in the same format at the initial level. Data pre-processing mainly involves filtering operations and adjustment of data suitable for further processing or storage in the cloud server. Biosensors are usually equipped with poor network connectivity. They cannot directly connect to the extensive network like WAN, wide area networks. This gateway provides a platform for data connectivity with such an extensive network by Bluetooth or Wi-Fi. Apart from Bluetooth and Wi-Fi, other wireless protocols such as RFID and Zigbee are also used depending on various constraint and requirement. Servers are the central component of IoT systems that detect and analyze abnormal activity. The gateway transfers the digital data to the server or the cloud for data processing from biosensors. The process of identifying crucial information regarding biosignals is known as data mining in IoT. Various algorithms from signal processing and artificial intelligence are the part of cloud server. The server processes data received from various resources in order to provide meta-analysis. This is the IoT framework for monitoring the health condition of COVID-19 patients. In this framework, we can see the three different layers. At first layer, we have the raw data collection from biosensors, Bluetooth connectivity. We can have either Bluetooth connectivity or a Wi-Fi connectivity. The second layer consists of the mobile device equipped with the mobile web application, in which the backend receives the raw data and front end provides the interface to the next level. The front end also supports the visualization of data, which can be used as some meta-analysis for the user. The processed data now sent to the third level, that is the cloud server. Here the distributed, this is the brief overview of the data used for initial level analysis. We have 472 patients with mean age of 57 years. In this group, we have 398 patients recovered successfully, whereas 74 patients outcome as the mortality. Here in this data set, we have different health marker. We consider them as the features such as blood oxygen level, shortness of breath, cough, fever, presence of heart disease or other chronic disease, etc. With the increase in the age, because almost 47% of the population which met with mortality were between 76 to 90 of age. One more observation is that if you look at this Venn diagram, 33 patients produced the low blood oxygen level out of 74 total mortal cases. After receiving the raw data, we use recursive feature elimination method to find out the ranking of different features, that is the blood oxygen level produced the highest level of information about the mortality case that we have seen obviously in the previous raw data also. Then we have observed shortness of breath, later on coughing, then fever, then heart disease, other chronic diseases, myalgia and diabetes. So after finding the importance of health markers, we labeled each patient with different categories having the health marker related to mild, moderate and serious symptoms. We have mortal outcome, whereas almost 95% of patients have recovered successfully. In order to automate this process, we trained machine learning algorithms with split of 70%, 30% for training and testing respectively. We found SVM is better compared to KNN in terms of accuracy and specificity. SVM has achieved almost accuracy in the order of almost 1. This is the initial prototype development. In order to deploy the IOMT framework, we use 2 biosensors, pulse oximetry and body temperature for data. These 2 devices are interfaced with ESP32 that continuously transmitted the data to the mobile device through Wi-Fi protocol. Application interface at the backend was designed using AWS SDK to collect this data at the interval of every 10 seconds. The front-end design was developed using Unity software that facilitated the mobile devices to collect subjective data and visualization support. In this prototype, we used AWS platform to function as a remote cloud server. The SVM classification. So in conclusion, we have seen overview of health monitoring through IOMT framework. We propose the IOMT framework to use as a system to monitor health condition of COVID-19 patients. Important features are identified that can help to classify the health condition automatically using classification algorithm. We have developed an initial prototype to test the overall working of the system at implementation stage. Okay, thank you.
Thank you, Puneet. This was a recorded presentation, so we won't be having a Q&A session, so that actually ends the session for this morning. I'll be breaking forward. Well, thank you everybody for attending the session.